Welcome again to Kitchen Chemistry. Today we're going to talk about volume and significant figures. So you might be asked in a lab to get 100 milliliters of some solution. In this case I have water, but when you see something like 100 milliliters, then what that's implying is it's implying that you don't have to measure very accurately. What we have is a container, two different containers, and the 100 milliliters means you could be off by a fair amount. So I have a large beaker, and you can see the readings. There's a 200 on the bottom, and then there's a 400 and a 600. So each one of those lines represents about 200 milliliters, and this is about halfway up the 200 milliliter mark. So this is about 100 milliliters inside of a large 2,000 milliliter beaker. Here is also 100 milliliters, okay? Now in this case, there are no markings on this at all. So this is about 100 milliliters, but I could be off. Maybe it's as much as 200 milliliters. So this volume here and this volume here are the same, but they're only measured with one significant figure. Now, I also have another container in which there are graduations. And if we look at these very carefully, let's look. We see the 170, we see the 190, we see the 210, we see the 230. So each one of those long lines represents 20 milliliters. So we can see the 110, the 130, and then the 90. So here we are, our volume is about halfway between the 90 and the 110. So we're gonna call this 100 point milliliters. In this case, this volume is reading it's reading 100 point milliliters, meaning we have three significant figures, and my uncertainty is about plus or minus 1 milliliter. I could be a little bit over by 1 milliliter, I could be under by 1 milliliter. So here is a volume reading of 100 milliliters. And if we look here and if we look here, these volumes, this is a pretty good estimate for 100 milliliters as well. Quite ironic, okay, that these are 100 milliliters, yet this is 100 milliliters as well. Volume can be tricky because the height of something is very different. And finally, we have another container. We have our graduated cylinder. We have a cylinder that has no graduations. We have a large beaker. And our last piece of equipment is called a volumetric flask. So a volumetric flask, here's a flask, and it measures only one volume. The one volume it measures is 100 milliliters. Now there's a tiny line at the very top, and that line is there. So that line represents 100 milliliters. There we are, we can see it really well. The meniscus is right at that line. If we were to add just another tiny drop of water, we would say, there you go, maybe one or two drops of water. It would then go over the 100 milliliter mark. We can see that's above that level. And then we would try to go ahead and suck out that little tiny bit. So this is gonna go ahead and record 100 milliliters pretty much to the nearest droplet or so. Maybe it took out a little bit too much. So there we are, we're really close to 100.0 milliliters. So if in a lab you're seeing something where you're recording 100.0 milliliters, that means you need to measure that volume very, very accurately to the nearest tenth of a milliliter. Please don't spend all day trying to get 100 milliliters exactly if this is what is said in lab, 100 milliliters. If you need to get something 100.0 milliliters and need to be more careful, you're gonna have to use a more specialized piece of equipment like a volumetric flask. This has 4 significant figures, and this has only 1 significant figure. So hopefully this helps to understand the idea of how accurately we measure when we record different pieces of data.